Hello everyone. Today we will explore two prominent optimization techniques for large language models. That is supervisor fine tuning, that is SFT. Another one is the preference alignment, often implemented with reinforcement learning from human feedback. That is nothing but RLHF. So for advanced applications, understanding when and why to use each of these methods can be critical to building models that are both high performing and user aligned. So in SFT, we aim to find parameters theta. So there is a loss function theta star is equals to augment theta and sum over xi yi belongs to data set and there is a loss function, right? So in SFT, what we do, right? We aim to find parameters theta that minimizes the error between the model's predictions and the labeled data, right? So we use loss function, typically cross entropy, that tells the model how far off its predictions are from the correct labels. So this method is ideal when you have well-defined outputs and high-quality labeled data, as it allows for consistent and reliable model performance. To think of SFT as training by giving the model direct instructions. That is, it's like teaching a student through rote memorization. You show them examples and they learn to respond in predictable ways. This makes SFT great for tasks with clear structures and defined answers, where consistency is key, because the method doesn't involve iterative feedback. It's also more resource efficient. Whereas the preference alignment, which often uses reinforcement learning with a reward model, RFE, right? You can see the function that is inside the expectation. There is RFE is nothing but it is a reward model whose parameter is the fee. Okay, so what RFE does is it scores the alignment of the model's outputs with the human preferences. The optimization objective here is to not to minimize error, but to maximize this reward. So RLHF, that is the reinforcement learning with human feedback, involves iterative feedback loops where the model continuously updates based on human feedback. This approach is highly flexible but computationally expensive, making it well suited for tasks with subjective or complex responses. Whereas PA is like so let's look into the preference alignment. The preference alignment is like training by nuanced feedback rather than rote instructions. Imagine teaching someone to play a game, not by telling them exactly what to do each time, but by rewarding good moves and penalizing bad ones. Over time, they develop strategies that align with human feedback given. So this makes preference alignment particularly useful for tasks that require human-like understanding, empathy, or ethical considerations, as it allows the model to interpret user preferences rather than relying on a very strict rules. Let's compare the SFT as well as the preference alignment. So on both mathematical and practical fronts. SFT is efficient and reliable, producing consistent outputs when you have a high quality labeled data. However, it's limited in flexibility for subjective tasks. Preference alignment, on the other hand, is adaptable and powerful for nuanced and user-centric applications. But it comes at high cost, both computationally and in terms of complexity. So additionally, RLHF may inadvertently teach the model unintended behaviors. This is known as a reward hacking, where the model optimizes for the reward in ways that don't align with the actual task goal. So to determine which of the method is best, considering the data quality, task complexity, and available resources, right? So SFT is more efficient and straightforward if you have a structured, labeled data and predictable outputs. Whereas preference alignment is preferable for complex subjective tasks where output need to adapt to user preferences, although it requires a higher budget and computational power. This decision framework helps in understanding which method aligns with your model needs and constraints. Let's see how these methods play out in a real world applications. For example, in a product question answering model designed to answer straightforward questions can use SFT as the answers are generally consistent and fact based. But a customer support chatbot that interact with users in a conversation and personalized manner would benefit from preference alignment here. Here, it's essential for the model to pick up on tone, context, and user preferences. So, making PA a better fit for aligning with a user expectations and delivering a nuanced experience. So, in summary, like to wrap the things up, so out of SFT and the preference alignment, which one is the best option, right? So SFT is the best option for structured, predictable tasks where you have the label data, while preference alignment excels in cases where you need nuanced alignment with human preferences. Both methods have their place depending upon the complexity of the task and alignment requirements. Always start by assessing the task structure, data quality, and the nature of users' interactions. This way, you will be the well equipped to decide which approach will create the best performing and most aligned model. Thank you.